So hello everyone. I'm introducing Fastft, which is essentially like a fast short-time Fourier transform implementation in C based on the fastest Fourier transformation in the West. So the whole idea is you mostly like train in Python for audio features extraction. Notably the STFT you use something like TensorFlow or PyTorch implementation, but often also people use Librosa, like in the case on Splitter and MostNet. This implementation in Python is quite limiting, so when you try to do the inference, you are limited to using the same flavor to have the same results. So to attempt to solve this, I present Fastft, which is like a C implementation of the STFT algorithm. It's similar to Librosa in the way I just check that they deliver the same results, I implement the same algorithm, and the whole idea behind this is later on I can use this STFT extraction algorithm with neural networks so I can do certain prediction or synthesis algorithm that are similar, so you can train in Python and deploy in C. So the whole idea is to get this small picture of a spectrogram. Here you'll have your neural network, and you can do, like, for example, in this case, like synthesis. The example that I'm going to present will take like a magnitude spectrogram, apply some neural network to it, and then give a score, which is a quality score. So this is the idea of MostNet, which is like objective assessment for voice conversion. Essentially, like you'll give it an audio and then it gives you a score from between 0 to 5, quantifying the quality of the resulting audio. So this is essentially like the motivation and the general idea of Fastft. Yeah, you can see the library is quite documented, and I included a comparison between like the Python Librosa format and between like the C to see that they deliver the same results. I also like included like a small example of the C MostNet. This is what we're gonna run now. So similar to what's in the README, essentially you have two versions. You have the Python version, that's the original one, and then you have like the C version that's based on the Fastft. I already like built the project to spare us some time. The instructions are in the README, and let's simply run the Python version. So essentially you'll need to load the model, extract the features, run the inference, and then here you have like a mean opinion score average, so it does like many inferences per frame, but then you get the average at the end. And then this is essentially like the C version of the same algorithm, and then you get to the second element after the comma correct element, and it's way faster. So you can see this is like 4.25 seconds and this is like 0.17. At the same time you can see the CPU usage is a little bit higher, but then you have like total usage is less, so it's a more efficient, and then you have like more manipulation possibility with the C version. So this is essentially the motivation behind it, and you can see like the huge difference in latency. This will be very useful in embedded systems and real-time systems.